all the methods to derive exponential function, logarithm function, sine, cosine, and tangent. So 5 new rules we have learned. Well, just add another line. Quotient rule. That's the quotient. I forgot to type that. So the top one is product rule and the second one is quotient rule. But before we talk about product rule and quotient rule, well, another one we have is chain rule. We have learned that last week. But what I want to say is do not use quotient rule or product rule unless necessary. There's a lot of things you can simplify first and like change the form, rearrange it, and we can easily derive it by the most simple formula. So unless we really need it, otherwise do not use product rule and quotient rule. It's very hard, okay, very complex. You can see that later. For example, the first one, I know like log e something, I want to derive it, I need to derive the inside first and then over like the inside. But if I want to derive this one, okay, if I want to derive this one, I need to use chain rule, okay, I need to use chain rule. But I don't want to use chain rule because that's a log, okay, log is the easiest one to derive because I can write this as log e 3x minus 2 to the power of a half and minus, okay, log e m over log e n, I can write log e 4 minus log e x squared minus 1, but there are a whole like one number, so I need to bracket that. So use the formula we have talked about here, log e m over log e n, that's log e m minus log e n, so we subtract it. Why, okay, again, why we subtract it? If we don't subtract it, I need to, well, I can put that as 4x squared minus 1 to the power of negative 1. I need to derive it by using chain rule again. Okay, I don't want to use chain rule. That's harder. So, or you can use quotient rule. I don't want to use quotient rule. That's why I separate the thing. Okay, I separated it. That becomes log e4 minus log e x squared minus 1. I can easily derive x squared minus 1. I can easily derive like 4. So it's easy. Okay, it's easier. And also to the half can be dragged into the front. What I left is a half log e 3x minus 2 minus log e4 plus log e x squared minus 1. Okay, plus log e x squared minus 1. So I can change the formula into this form, which allow me to derive it really easily. Okay, so derive 3x minus 2 is easy. Derive x squared minus 1 is easy. Everything is easy to derive in this case. So my f dash x equals to a half 3 over 3x minus 2. Right? Derive the inside, we have 3 and then put it over that. What's the derivative for log e4? What's the derivative for log e4? Nothing is 0. I'll have 0. That's a constant. Okay, log e4 is a constant. If a constant, that's just 0. And then plus the derivative of that, that's 2x over x squared minus 1. Okay, so f dash x equals to 3 over 6x minus 4 plus 2x x squared minus 1. Okay, that's what we should do. Okay, look at C. What's the derivative for tangent? Sec squared. Okay, so h dash x. Well, I can derive the inside really easily, so I will directly derive it. So that becomes 3 sec squared 3x minus 2. Okay, derive the inside and put it over this. Okay, just tell you a joke, like don't feel so sad. I'm not sure if you have seen this, like I think I see this on the website. Sine x divided by n. And what that equals to? 6, right? Like the n get cancelled. I think that's like, it's really a joke. Okay, I think it's really a joke. Until last week, I really see something. I give this question to a student, which is not our like student. And then he up to this step. And I said like, if you can simplify, you can simplify it a little bit. And what happened is, he did that. It's serious, like he did that. And then the answer he gave me is that. I just realized, wow, there's something really could happen to students. Like they can't see like it's a whole thing together. So that's the final answer. And I said, where's your x? He said, cancelled. I was like, oh well, we need to back to the start and then relearn everything for circular function maybe. So that's something could happen. But I believe you won't do that. Okay, so that's the answer. So how we can simplify it? How we can simplify it? Sec, what, okay, my answer can leave like this. Okay, my answer can leave like that. But why we won't keep the answer like this? Because if I ask you to evaluate what's h dash pi over 4, for example, do you know what's sec squared pi over 4? Do you know how to evaluate sec squared? You will put into the cos and sine, right? Remember what is sec? Sec is 1 over cosine. Okay, 1 over cosine. So what I will do for evaluation is I will put it all into sine and cosine. So 3 sec squared is 3 over cosine squared 3x minus 2. Okay, times 1 over tangent 3x minus 2. Anyone know what is tangent? Sine over cos. And because it's a 1 over, so it's a flip, right? Like you flip it. So that is a cos over sine. That's a cos over sine. So I can cancel this, okay? I can cancel this. So you will have 3 over sine 3x minus 2 and cosine 3x minus 2. And a little bit extension for special student. That's a half sine 6x minus 4. Well, you don't need to know that, but that's for special student. Okay, special student should know that. So that's half sine 6x minus 4. You don't need to write this down. I can leave my answer just like 3 over sine 3x minus 2 and cos 3x minus 2. Nothing wrong to leave your answer like this. Okay, your answer can be in that form, but the only thing is I can't evaluate it. Okay, it's hard to do evaluation. I know sine, I know cosine, but I don't know what is the value for sec. So I will put into the sine and cosine form for evaluation. Alright. Sine rule and cosine rule. Product rule and quotient rule, what I'm talking about. Product rule and quotient rule. So as you know, we can do derivative adding together or subtract. So we can derive them separately and add or subtract them for derivative. But if you have two functions times together or divide, you can't derive it by derive separately and times them or divide them. That's not working. So therefore, we have the product rule and quotient rule. Okay, we have the product rule and the quotient rule. So what is the product rule? Is ux and vx. So how we can differentiate ux times vx? We will derive one and keep the same for the other one, and then reverse it, like derive that one and then keep the same for the second one, and then we plus it. So you keep one and then you derive one, and then you keep the other one and derive the other one, and then plus them. Which one derive first and then second doesn't matter because it's a plus. So you have two things add together. So that's the product rule. And for the quotient rule is 3 component. I said it's 3 component. The first component is square the bottom. Okay, square the bottom. You have the bottom, whatever is squared. And then we will derive the numerator first and keep the denominator. Then you will derive the denominator and keep the numerator. The order is important in this case because it's a minus. Okay, because it's a minus. Which one you derive first, which one you derive second, that matters. So you remember you derive the top first and then bottom. Okay, derive the top and then derive the bottom. And the other two keep the same. Your bottom needs to be squared as well. That's the quotient rule. So try B and D. Okay, try B and D by using the product rule and quotient rule. See what answer you can get. And trying to wait, one thing I want to talk about. Expand and simplify. Okay, that's the thing. Simplify. Factorize doesn't mean simplify. Okay, you should understand that. Expand is expand. Expand means there shouldn't be any bracket. The question, I'm not sure if you remember this question, that is the test first question. They ask you to find what's FGX and then ask you expand and simplify. Okay, expand and simplify. Expand means, well, I can't remember what's the exact question, what the answer is, but it's about 2x squared plus 2x plus 4, something like that, or 4x squared or 4x squared plus 4x plus 2. I think it's that. The answer should be this. Okay, that's the expand and simplify form. What means expand? That's expand. No bracket, no common factor, nothing factorized. Simplify means all the terms collect together. X squared term collect together, x term collect together, constant collect together. That means by simplify. I see a lot of students give me this is the second last line, and the next line go 2x squared plus 2x plus 1. That back to the factorized form, okay? That back to the factorized form. This is the factorized form already. And that's the other class asked me, well, I see expand, so I expanded, but I also see simplify, so should I go for that? No, you're not going for that. Like simplify means if there's any, for example, 2x squared divided by x, you need to simplify it to 2x. If your question have like 4x plus 2x and plus 2x squared, you need to simplify it as 2x squared plus 6x. That means simplify. Okay, you collect similar terms, you cancel things, you do anything unnecessary like that, combine them, not factorize. Okay, factorize is factorize. Expand is expand. They can't exist at the same time. When you see expansion, means no bracket. Okay, no bracket at all. So it's all plus or minus. And simplify means you collect similar terms. That means simplification. A little bit confusion, like I can see from the previous class. Just make it clear here. So expand means there's no bracket. You can't factorize it. Okay, so you can try B and D now. Okay, you can try B and D. Okay, the first one we need to use the quotient rule. So g dash x equals to, well, first of all, think about the numerator. The numerator will be derive the top first. Okay, derive the top first. You derive the top here. So the derivative of a sine will be a cos. And you derive the inside. That's 3 cos 3x. Then you times with the bottom. And that needs to be minus by, you derive the bottom, so you keep the top. And then you derive the bottom, that is 2ex minus 1. Okay, that's what the top looks like. Over 2ex minus x, and then squared. Have you done? Done? That's the derivative for g dash x? Yes? There is something missing. Minus 2 is missing. We don't need to, well, don't try to expand and do something unless they told you to do that. Unless if you expand, it becomes too complex. Okay, otherwise it becomes too complex. So that's the derivative for g dash x. Let's have a look at kx. Yeah, leave the answer like that. Okay. To product rule. Okay, for product rule, what I normally do is like to avoid confusion, like that's ux times vx, right? That's the ux, that's the vx. I would derive them separately. So what's the derivative for cosine 3 minus 2x? Well, what do you need to do? Well, I just want to know it's positive or negative. Cos will become negative sine, but the answer for this question is should be positive or negative. Positive, because we have the derivative of inside, we have negative 2, and then sine, cos become negative sine, and 3 minus 2x, and that is a positive 2, right? Positive 2, that. So the derivative is 2 sine 3 minus 2x. What's the derivative for this one? What's the derivative for the next one? What we need to do, or tell me what we need to do. What we need to derive. The power. The power is sine 1 minus 3x. Okay, we need to derive the power. So I will have a negative 3. Sine become cos 1 minus 3x. That's the derivative of the power. And what else we should have? E sine 1 minus 3x. We repeat the thing again. Okay, we repeat that again. So what we'll do is we'll times it this way. Okay, we'll times it this way and then add them together. So k dash x equals to, well, I can go to do that one first. That's a minus, the derivative of that is a minus 3 cos 1 minus 3x cos 3 minus 2x e sine 1 minus 3x. Okay, 3 things times together, and plus 2 sine 3 minus 2x e sine 1 minus 3x. Okay, just times everything together and plus that. Well, I can't really simplify much about it. Like, can't simplify much because, well, I can't really expand it or do anything. So that's the simplest answer. Just keep it like that. Just keep it like that. All right. Wait. Well, shouldn't have any problem. You don't need to copy the answer from the screen. What's wrong? Derive the top. Derive the top. That gives you negative 3 cos 1 minus 3x, and then times with that cosine. That's the 2 cosine. Any questions? No? Okay, if you don't have any questions, can you derive the next question? Like derive the f dash x. So I want to find an expression of f dash x. I want to find an expression for f dash x. Well, this question asks us to find f dash 4, and you know you can't find f4 first and then derive. If you find f4 first, that's a number, and you derive it, that become a 0. So you can't do that. So therefore, we need to do f dash x first, and then put the 4 in, and then put the 4 in. So that's what we need to do. So have a think how to use quotient rule to find f dash x. How to use quotient rule to find f dash x. Okay, so first thing, like I see in this class and the other class, like when we use quotient rule, the bottom is the Vx already, okay? You not flip it, you not make a negative power to it. So it is Ux is Gx, and then your Vx is square root x, or say that's x to the power of a half. You don't say negative a half, okay? When you use quotient rule. Use quotient rule, the bottom is just like what you can see there. You not flip it, like make a negative power. So what we'll have here is, we will derive the top first. We have g dash x, and times the bottom, that's square root x, minus the derivative of the bottom, that's a half x to the power of negative a half, and times with gx. And the bottom is square root x squared equals to x. Okay, that's what we have. And we sub 4 in, okay, we sub 4 in. So f dash 4 equals to g dash 4 times root 4 minus, well, see what's here? That's 1 over 2 root 4, right? 1 over 2 root 4, because that's 1 over 2 root x. And times g4 over 4, and f dash 4 equals to g dash 4 is 6 times 2 minus 1 over, that's a 4, times 8 over 4. F dash 4 equals to 12 minus 2 over 4, and that is 10 over 4 and 5 over 2. Okay. Okay, that's what you have. A lot of calculation error. Okay, a lot of calculation error. So just pay attention to that. Any questions to this? Any question to this? Okay, if you don't have any question, I will save this.